The Dirac delta function. Motivation: pushing a cart, initially at rest. F. Applied impulse. Acquired momentum. F. T. F. T. mv. mv. T. Same final momentum, shorter time. In the limit of short time, we idealize this as an instantaneous, infinitely large force. mv. mv. T. T. Dirac's delta function models for this kind of force, Dirac delta function. This unit impulse function is defined by the conditions. Representation. T. Normalization. Q. Is this mathematically rigorous, using standard calculus? Not quite. Standard functions do not take infinity as a value, and that integral would not be valid. How to make sense of it then? What physicists like Dirac, early 1900s, meant is something like this. Mathematical difficulty: in standard calculus, this family of functions would not converge. Later on, 1950s, mathematicians developed the theory of distributions to make this precise. This generalization of calculus is beyond our scope, but we will still learn how to use it for practical problems. W. T. Calculate. TU 1 ton remark: value at t equals 0 is not well defined. We adopt 1 by convention. Unit step function. U. 1. T. In standard calculus, ut is only differentiable, and is zero derivative, for non-zero t. Ut is discontinuous at t equals 0. Value at point of discontinuity is arbitrarily chosen. Step function as a limit. 1. T. T. Remark: physical variables, for example the car momentum, are not really discontinuous, they are more like. The step function ut is a convenient idealization. Example: integrate last term, fg 1 ton step function used to. Compact formula. T. G. 1. F. Due to. Jump. Standard derivative. Away from t equals 0. Scaled steps and deltas. 3u. 3. For example. T. K. Representation. W. T. Conceptually the same, different. Amount of impulse supplied, negative steps and deltas. U. T. minus 1. T. minus 1. Representation. Or. T. minus 1. Reverse step and its derivative. 1u. 1. Strictly speaking, the two expressions differ at t equals 0, but recall u0 was arbitrary. There is no distinction between the two in this calculus. Differentiating the left-hand side. Using right-hand side composition rule. Del2 is an even function. Translations and flips of steps and deltas. 1. 1. T. T. A pulse function. A. B. T. Example. T. F. 2. Using the first expression. 2. T. Using the second. Different answer. A basic property of delta. Let ft be a standard function. If ft is continuous at. If ft continuous at. F. 1. Equals. T. T. Apply to the previous example. Consistent with previous answer. Consequence of our basic property. Similarly. 1. A. B. T.